Okay. So the fourth sim chemistry we are having of that one. Know that the syllabus of that one. And second, third blocks are organic pots. We are having of that one. And fourth block is physical chemistry. Okay, fine. So today only two are the participants are present. Only two. Right. So in that four blocks, the first inorganic chemistry we are having the first chapter is D block elements. Second chapter is F block elements. And third chapter is coordination chemistry. So my voice is audible now? One
Yes, sir,
person
it's
is
audible.
left.
It's audible.
Okay, right, right. Okay, fine. Okay. So the first block is nothing but the total inorganic parts in the D and F block and coordination chemistry. Here D block also, you know that one D block elements which are having of the up to now the notice it is 34 elements are there. That means 3D series, 4D series, 5D series, 6D is the incomplete series. That is 3D series is consisting of 10 elements, 4D series consisting of 10 elements, 5D series is consisting of 10 elements, 30. And then the 6D previous periodic table, if you see that when we are having of only 4 elements are there. Now today it is announced as 120 elements. Okay, but old syllabus point of view, 4 elements only. So total you are having of the 4 series, 3D, 4D, 5D, and 6D. On this basis, you are consisting of the electronic unification as well as the remaining properties also you can learn in this chapter 3D. Okay. Next, coming to the F block elements, you are having of the 2 series are there. That is 4F series and 5F series. There is lanthanides and actinides. So same similar properties are there, and those belongs to the F block elements are belongs to the third B group elements only. That is number 3. It belongs to the 3rd group only. That is, you have to study about the properties similar like the D block elements. Here also you can see the electronic configuration and remaining other properties, metallic character and everything in the F blocks. And next chapter is the coordination chemistry. In that coordination chemistry, we are having the little bit idea about the coordination, that is double salt, and also we are having of the what is the coordination number, what is the metal ion, ligands, that everyone you have to covered in the coordination chemistry that you have to learn in the third chapter. So this is belongs to total 3 chapters or belongs to the our inorganic chemistry. And coming to the organic parts, that is organic chemistry 1 and organic chemistry 2. Two blocks are there in this. In that organic chemistry, you are having of the first organic part, you are having of nitrogen compounds, nitrates, so nitroalkanes. And second unit also nitrogen compounds belongs to the amines. Amines are present. Those who are learn about in that amines. And the stereochemistry. Next is the stereochemistry of that one. So mainly important of this one organic part is we are having of nitro compounds and amines. Mainly important on this one. Third chapter, the stereochemistry is a little bit of the mechanism is involved in that you have to learn in this case. This is about the second block. Now coming to the third block, we are having of the carbohydrates. Carbohydrates 1 and carbohydrates 2. So very simple. This is also already you are familiar with the carbohydrates. What do you mean by the carbohydrates? That means you are having of the classification is there. The carbohydrates in that classification, you are having of the classification carbohydrates are classified into 3 categories. Okay, monosaccharides, disaccharides, and oligosaccharides. Like that, you have to study about that one. In that main, not only that important the classification, it is also for the 5 marks question, it is important, but the structural elucidation is important. You have to find out the structure of the glucose. and glucose other and of fructose also, furanose, and so many other reactions which are present in that organic part, that is a carbohydrate, in the second chapter. That is about the black 2, that means second inorganic parts, sorry, organic parts. Now coming to the fourth black, it is a physical chemistry. Here the physical chemistry we are having of that one, little bit of theoretical part is there, thermodynamics, electrochemistry, and kinetics. Actually, it is a very lengthy chapters and very big one, and also you are not familiar with the in your whatever the studies up to now. Okay, this is a particularly thermodynamics. If it is a physics candidate, you can read about same thermodynamics which are present in the physics. Same it is repeated in the our chemistry also. But the you are having of electrochemistry and chemical kinetics. There is a two units are there, which is a separate one, which are present in that one. Okay, this is about the our complete picture of the syllabus of your fourth sem. The fourth sem syllabus is only the few chapters which are present in that one, and in that the first block is inorganic part. In that inorganic part, you have to think about yours. There is a main important of D block elements, A block elements, and coordination chemistry. Okay. So my suggestion is for this particularly first block, second block, third block is very easy to get the your score 80 marks. Means if you are already I told that if you are follow the two blocks, you will get the 60 marks compulsory. If you thoroughly the two blocks means inorganic one block and organic suppose and organic physical, that is if you are throwing any two blocks you will getting of the 60 marks question. If you are throwing of the three blocks means you are getting of 80 marks also. So that is easily to get one your score. And now what you are thinking about now today you are from the first class, this is from today onwards we are having of the continuous 6 classes are there. You go through these all the things which are having of that one, that means first chapter and second chapter and third chapter. The unit 1 which is a D block, unit 2 is the A block, and third is the coordination chemistry. In that coordination chemistry some of the students will be a little bit here only the thing is you have to learn here what is the coordination number, what is double salt, what is ligand, what is metal complex, what are the complex which are formed in that case, and also some theories are there. Werner theory is there, crystal field theory is there. From that, how the electrons will be distributed. If Werner theory, how the molecules are present in the primary valence state and secondary valences. From that, you are getting of the coordination number. This is about the overall picture of this particular first black. Okay, so you can easily get it out from this black means why, because already we know that the 3D black, that means D black elements, D black elements, D black elements, always the black elements. The second which is present in the D. So the elements are called as D elements. Transition elements. Why it is called as a transition elements? Again the question. The transition elements means it is in between the S and P block, you are having of the D block elements are there. In between, that is transition means in between. That is called as a transition element. So in between the S and P block, the elements which are present in that, those are called as transition element. But here one the condition is there. So if you see the 3D series, 3D series elements means you have to remember the 3D series at least. Why? Because we are having of the 4 series are there, 3D, 4D, 5D, 6D. At least one series, 3D series, the elements we know that from the scandium to zinc. Scandium is the 21st element in the periodic table. Okay. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. This element you have to remember compulsory without knowing of other 4D, 5D, 6D. Least bother about that one. But better to remember this series, third series. Why? Because the question will be appear like that only. So you can see that one. What is the 3D series? That you have to at least practice it. And also this particular 3D series is start from the scandium. Scandium is the 21st element in the periodic table. Okay. In the same, these elements in the periodic table comes under third B group elements. Third, that is a Roman letter, third B group element. Or it is comes under the, according to the Indo-Arabic number 3. Third group elements only. So these are all our transition, means in between S and B is called as transition. But zinc, cadmium, mercury, that is zinc, cadmium, mercury, these are called as second B element. It is nothing but you are having a 12th group element. Zinc, cadmium, and mercury is the completely filled d orbital. That means the electronic configuration of this one is 3D series is consisting of n-1 d1 to 10 ns2. So it is nothing but the 4s2 and 3d10 completely filled d orbital. So d block elements, the electrons are completely filled. Those are called as not transition. This is the 3D black elements. 3D, you have to remember the general electronic configuration. What is the general electronic configuration of d block element? n-1 d1 to 10 ns2. This is the general electronic configuration of d black elements. What I say is from scandium to copper is transition elements. Zinc is the last element. It is not a transition. It is a d black element. So the concept of the why it is transition, why it is not transition means if any element is having of completely filled d orbital, that is not a transition element. That means whatever the properties are resemble, whatever the properties of showing of the d black elements, the last element that is completely filled d black element not show. Due to that reason, scandium to copper is called as a transition element. Zinc is a d black element only. You have to remember that. So transition, actually the meaning is in between. But here the concept is just a transition element showing the certain properties. Mainly d black elements showing of the properties are, you know, that one is the good metals. They are showing the good conductors. And it acts as a catalyst, but best catalyst, and can form the color compounds. See, variety of the properties are present in the d black elements and the formation of the complex compounds. Such a type of properties does not show by any other elements in the periodic table except transition and inner transition elements. So our scientists are keeping of that particularly mind. Those are kept into the in between element, the black element. In that, in the same third group element, you are having of next series after the scandium, okay, lanthanum, yttrium, okay. So this is the element which are present in that one. You are having of the lanthanides is there, actinides is there, same group which is presented. So if you see your textbook, you are having clearly idea is the given. Here having of the specific properties are there. For such elements, you're showing of different properties. These different properties are except for the particularly D and F black elements. So tomorrow onwards, I can clearly clarify the doubts, whatever doubts. Why? Because today I am outside of the classroom. So due to that reason, I am unable to see the whatever the your blackboard means. I can't write on the blackboard today. Tomorrow onwards, we'll explain clearly that whatever the elements which are present. Okay. First of all, you learn about what is in the D block element. You have to learn first you have to learn D block elements is general electronic configuration, and also you have to remember at least one series, that is 3D series. It is easily to remember. Scandium to zinc. That means you are familiar with up to 20 calcium. After the 21st element is the scandium. Up to 30 zinc. So 10 elements names you have to remember. In that, first question is write the electronic configuration of 3D series. Or the question is write the electronic configuration of any one of the D block elements or any one of the series of the D block. So if suppose the question is asked, you have to write this 3D series. Write the electronic configuration from scandium to zinc. Here the two exceptional cases are there, chromium and copper. Chromium is the 24th element in the periodic table. Copper is the 29th element in the periodic table. So these are the anomalous properties shown by the chromium and copper. Here, mainly D block elements, the common oxidation state is +2. Common oxidation state is +2. But except the chromium and copper showing of +1 also. Why? Because if you're writing of the chromium electronic configuration, that is 24 atomic number. If you see the 1s2, 2s2, 2p6, 3s2, 3p6, 18 over, 4s2, 20 over. 24 means still 4 electrons will be there. That will be goes to the d orbital, 3d4. 4s2, 3d4. But actually the D block element is having of 5 degenerate orbitals are there. 5 degenerate orbitals which are present in the D block. Here we are having of only 4 electrons are present. If a atom is having of 5 degenerate orbitals are occupied half-filled or full-filled. If any atom occupation of the electrons half-filled or full-filled, that atom is more stable than incompletely filled d orbitals. Hence, in this case, what happens, special case of the chromium, s orbital electron is jumped into the d orbital so that the electronic configuration is modified as a particularly chromium. It is 4s1, 3d5. So due to of the 4s1 and 3d5, the chromium atom attaining of extra stability. This extra stability, this is called as anomalous property of the chromium. That's why the chromium shows +1 oxidation state. But all commonly 3D series common oxidation state is +2 only, except chromium and copper. Similar manner, copper. Copper is the 29th element in the periodic table. Copper also, if you show that 29th means it is nothing but 4s2 3d9. 4s2 3d9. If one electron is present in the copper, it is nothing but 3d10. 3d10 means fulfilled d orbital. Fulfilled d orbital is again stable atom. So due to this reason, what happened? This particularly, again the s orbital is jumped into the d orbital, formation of the extra stability purpose. So that the copper actual 4s2 3d9. But according to this anomalous property, it's showing of 4s1 3d10. So this particular atom attaining of extra stability purpose. These are the two exceptional cases which are having of the in the 3D series. Total among the 34 elements, 34 elements are present in the D block. In that, anomalous property, anomalous electronic configuration, I can say not only property, particularly electronic configuration, 10 elements are present in that 3D series 2. Okay, remember that's it. So remaining other, I can write down in the tomorrow. Okay, so what are the element which are comes under which group, which series? Okay, why? Because you are having of the peculiar properties are there. For the your advanced knowledge purpose, I am saying of the total 10 elements are showing of anomalous properties. Okay, like that. Here, writing of the electronic configuration, write the electronic configuration of all. Scandium means it is 4s2 3d1. Titanium 4s2 3d2. vanadium 4s2 3d3, chromium 4s2 3d4, but it is not correct. 4s1 3d5 is correct due to of attaining. According to the above principle, 4s2 3d4 is correct. Okay, but here this particular chromium can showing of anomalous property to getting of the extra stability. Due to that reason, it is showing of different electronic configuration. Manganese 25 fifth element, so it is 4s2 3d5. Iron Fe ferrous 26th element 4s2 3d6. Like that, you have to write all the elements electronic configuration except the chromium and copper. Specifically, they will ask the what is the electronic configuration of chromium and copper. 5 marks bit again. You have to remember. Okay, this electronic configuration. After that electronic configuration, here you are showing of the electronic configuration 4s2 3d something is there. That means two electrons which are present in the outer shell, 4s orbital. That means fourth orbit. So the common oxidation state is +2. Like that, if you see the scandium, +2, +3 also possible. Okay. Titanium, +2, +3. Like that, we are having of that one, +4 also. Vanadium, chromium, manganese, like that you are getting of this. Here, the maximum oxidation state is present in that particular element is manganese, +7. +7 is showing of manganese. Why? Because it is a 4s2 3d5. +2 is okay. Why? Because if you remove the electrons from the s orbital, remaining 5 electrons which are present in the d orbital, so that you are getting of the +7 also. So manganese can showing of different oxidation states of +2, +3, +4, +5, +6, +7. If you see, observe that +7 oxidation state in which compound you can present. You know that one? The +7 oxidation state showing of potassium permanganate, KMnO4. In this, manganese is oxidation state is +7. If you see the before that one, chromium. Chromium showing +6 oxidation state. Potassium dichromate, K2Cr2O7. In that, chromium is +6 oxidation state only. So that is the possibility of writing. So first remember, write the electronic configuration, then the properties are there. What are the properties means? D block elements can exhibit metallic character. Already I told that these are the pure metals, all are metals. So how can you remember, how can you know that the metallic character means? What is the characters of the metals? Always remember, metals are hard in nature, ductile in property, and luster in nature, and also malleability is there. These all the properties. If any element showing us, that is element is called as a metal. Here the D block, all the D block elements, not only the all D block, F block also showing of metallic character. All are metals only. They showing the property of ductile nature, malleability is there, lustrous is there, good conductor of heat and electricity, and also these D block elements can exhibit as catalyst. Nickel, iron. If you see that nickel, always the catalyst, a good catalyst. Iron is using of the catalyst. Copper sometimes. Okay. Ferrous sometimes. In the Haber's process, preparation of ammonia. That purpose we are getting of this one. These are all good conductors. Not only the conductors, they are also good catalysts also. What do you mean by the catalyst? Catalyst is nothing but they can speed up the reaction, but does not involve the chemical reaction. That is called as a catalyst. Here, the showing of that one, hydrogenation of oil. So you are using of the vanaspati oil, that is a vegetable oil, is converted into edible oil by means of hydrogenation in presence of nickel catalyst only. Without catalyst, the hydrogenation does not take place. This is the property of the catalyst. In many industrial purpose, preparation of anything, the catalysts are using. It can motivate the reaction, but does not involve in the reaction. That is called as a catalyst. Sometimes not only the catalyst, the promoters also using. Promoters means the catalyst efficiency will be takes place a good character. That means increase the efficiency of the catalyst is called as a promoter. Molybdenum. Molybdenum is your fourth, fourth, that is a 4D series that will be having of osmium in the 5D series. You are having of that one. These are all the act as there is a promoters. So there is a lot of difference between the catalyst and promoter. Promoter is nothing but the it act as a efficiency, more effectiveness of the catalyst. That little amount of the substance is added to that catalyst, that will be both are does not involve in the chemical reaction. That's it. That you have to remember, so that you can easily find out that particular. So the properties are metallic character and different variable oxidation state. The question is always in the 10 marks question. Why D block element showing variable oxidation state? Explain. Why it is showing a variable oxidation state means the electrons are enter into the d orbital as well as the s orbital. S orbital after the shell, 3d and 4s, so that they can lose the electrons. Formation of the substances, complex substances. That's why they are having of this particular complex substance. That means it's showing of variable oxidation state. Just now I told that the scandium is there. Scandium, what is the electronic configuration is 4s2 3d1. That means +2 is the common oxidation state here. How we are getting a +2 means the last shell is 4s. And that in that 4s, we are having of the 2 electrons are there. If you are removing of the 2 electrons, +2 oxidation is common. Next, one more electron which is present in d orbital, that also removing of that one. Why? Because we are removing to getting of the stability purpose. Getting of the stability purpose. That is octet rule you are getting. So that is also removing. We are getting a +3 oxidation state also. Due to that reason, variable oxidation state is possible. Okay. I will show tomorrow this variable oxidation state in the V shape, V curved shape. Why V curve? If you write the scandium to zinc element in a horizontal line, scandium, common oxidations are +2. It also showing off +3. Titanium, +2, +3, +4. Vanadium, +2, +3, +4. Scandium, titanium, vanadium, +4, +5. Chromium, +1, +2, +3, +4, +5, +6. See, it is increasing. +3, +4, +5, +6. So, drastically increasing. It is a next coming to the manganese, +7. Means +2, +3, +4, 5, like that. It is also +7. Then after the iron, after the manganese, iron you are the ferrous. It is +6 only. See, if you see, again decreasing order, like that. So V-shaped curve, that means V-shaped oxidation states are present. It is called as a variable oxidation state of this one. You can remember this one. It is a very important for examination point of view. Okay. So this can you easily remember that one. This is the main important. And metallic character. So you are having of those are the malleable characters. There's a ductile in nature, lustrous in nature, hard metals, and good conductor of electricity also. They're showing off in your examination point of view. They'll ask only 3 questions are there. One is a D block element showing off variable oxidation state. Why? Explain. This is one question. Next question is D block elements are showing off color property. Why? Explain. D block element showing off magnetic property. Why? Explain. Okay, these are the 3 questions are very, very important. That means why they are showing off, because the color property, if you observe the color property, because the D block elements are showing off, there is a vacant d orbitals are present. Just now I told that scandium to zinc. Up to scandium to titanium is a transition element. Zinc is not a transition element. Zinc is not a transition. It is a D black element. So that we are using of like the magnet. That is particularly color property. Only the last element. It is a having of vacant d orbital. Due to of the vacant d orbital, the metals are showing of color property. Full-filled orbitals are does not show the color property. Zinc is full-filled orbital. It is not having of any color property. Only from the titanium to copper is exhibit color property. That is a color nature. Next, coming to the magnetic property. This is also same reason due to of the vacant d orbitals or unpaired d orbitals. Unpaired electrons which are present in that one, so that that element particular metal, that is a element showing of magnetic property. In that magnetic property, you are having of three categories of the magnetic properties are there: diamagnetic, paramagnetic, and ferromagnetic. Dia means it can repel. It is not having of the magnetic character. Para means it can attract the magnetic field. Paramagnetic. Ferro means more attraction will be there. Those are called as ferromagnetic. So D block elements can show the magnetic properties of three. Diamagnetic. Zinc is a diamagnetic, sir, because of fulfilled orbital. If it is a vacant d orbital, means unpaired electrons are there, those showing of the paramagnetic. So what about the ferro? Ferro means more attraction. Here the more attraction element in the 3D series is iron, cobalt, nickel. These are the three. FeCO(Ni). Continuation. These are act as a ferromagnetic in nature, more attractive nature. That's it. Compared to the para. This property you can learn in this chapter. Color property, variable oxidation state, and also magnetic property. The magnetic property is measured in the Gay balance, Bohr magnetons. Mu, it is right as you can write as mu. So the measurements will be taken as in the Bohr magnetons. Mu is equal under root of you are having of the magnetic equation is there. Tomorrow I will explain on the board. That is also okay. Just listen first of all. Here, what is the important topics which are present in the D block you have to learn. That's it in this particularly. Okay. So variable oxidation state, color property, magnetic property. These three are very important for your essay type question, 10 marks question. Next short bits are electronic configuration of D block elements. Right, any one of the series. And next is the what is coordination number? What is double salt? That you have to. Double salt is nothing but is a mixture of two compounds, but each individual does not lose its identity. Double salt is a mixture of two compounds, but each individual does not lose its identity is called as a double salt. Simply more salt, Epsom salt. You are having of the Epsom salt, more salt. It is having of KCl, MgCl to 6H2O. Two compounds are there. KCl is there, MgCl2 is there, okay, which is hydrated one. That is a double salt. Coordination number is nothing but how many ligands are surrounded by the metal complex. Metal complex means central atom. How many ligands are surrounded? That is indicated as a coordination number. What is the ligands are? Ligands are so many are there. That will be we can help in the coordination chemistry. That is the third chapter is there. Negative ligands are there, positive ligands are there, and also neutral ligands are there. Three types of ligands are there. Ligand is nothing but it is surrounded by the central atom. How many number of central? That means it is a complex substance. So that metal complex is a central, remaining other ligands or anions will be surrounded by them. Those are called as ligands. So these are the questions in the D block elements. I hope you can understand the D black elements. Very easy to get the 15 marks from this chapter. 10 essay type question, one is a 5 mark question. One is a question is the compulsory asking question, what is lanthanide cont? That is in the fifth black, a black elements you can see lanthanides. Okay, what is lanthanide contraction is there. But in the 3D series, only D black elements we are having of these are variable oxidation state, magnetic property, and also color property. In the color property, what is the gay balance is there? Sorry, we have to use in the magnetic property the gay balance from that Bohr magnetars, how the units are calculated by means of the ferro-farad and also diamagnetic case. Okay, these are the few that is chapter, that means topics which are present in the D black. You can elaborately why, because today I'm outside, due to that reason unable to write on the blackboard. So tomorrow I will clearly explain the what are these one. You can take the screenshot of that one, easily to remember in the examination point of view. I can explain everything. What is double salt? What are the examples? What is the coordination number? What is the complex compounds? Why the D black elements are showing off different complex compounds? Because of this, the reason is only that particularly vacant d orbitals. Color property, magnetic property, variable oxidation state, these are all everything because of only that one. So odd number of electrons which are present in the d orbital, that will be exhibiting of this properties. Okay, and also catalyst. So many cases we are using of catalyst, contact process, ABUS process. Okay, for that we are having of that one hydrogenation of vanaspati oil to convert into edible oil. Okay, these are all with by means of presence of the catalyst only, which are that catalysts are only from the D black elements. So this is the which are having of this one. So tomorrow you can discuss very clearly. Now I am leaving this class. Why? Because I am outside this there. Okay, so mostly only 3 members are present. So I remember. Okay, Josna is there. You are from Josna. Only one. Right, ma. Okay. So if any having of this one doubts regarding of this topic, D black element, I will explain again and again tomorrow also. Okay, with whatever the that is using of the blackboard. Today I am able to write on the blackboard somehow outside. So this is the reason why that one. So to earlier and wind up my class today class. Tomorrow we'll see that one. Okay, fine.
Thank you, sir.
Okay, ma'am.
Thank you, sir.